I'm Bryan Campbell. Like Mike said, I work at Google. Well, actually, I work at Waymo now. And I actually have a car that picks me up every day that's self-driving, which is pretty cool. I'm working on making sure our cars can drive in rain, fog, snow, and that's the reason why I'm actually programming here in Michigan for Waymo. I've been programming since I was 7 years old. I know over 35 different programming languages, and I'm here today to talk about Go, which is actually a language created by Google. When I started first working at Google, the very first thing I did was I built something on the web page, which pretty much everybody uses today, but it makes no money. And so at Google, everything is so large and everything's at scale. If you program something for the web page, billions of people are seeing it at a time. And so instantly, if I just launch it just for like 1% of the population or a quarter of a percent of the population, I saw that, I don't know, like 3 months into working for Google, I was automatically losing millions and millions of dollars. And because of that, you have to program in such a way that's like efficient and effective. And it was really small. I was just changing an icon, honestly. And so I wanted to talk about a language, Go, which is one of those things that was created out of need for something to be efficient, a need for something to be small, lightweight, scalable, which is Go. And hopefully, after I give my talk, that you all will be able to see the benefits from it and maybe something that you want to use yourself. Let me ask, how many people have heard of Go? Raise your hands. All right, cool. So one thing that people might not realize about Go is how solid it is. It's like one of those languages that's not trying to be like every other language. It's really trying to serve a specific purpose. It is very efficient. It doesn't use as much memory as it has to. It's like one of those languages that's actually fun to write, but is fast. For instance, it has its own garbage collector, unlike C++, but like Java. But unlike Java, it's actually statically typed, which means that when you're running it, it only runs the code that you wrote. It's not running the code you wrote plus some kind of memory management like JVM. It has no buffer overflow issues. It's safe and secure. And actually has built-in concurrency, which is actually very, very important. And that's actually one of the core reasons why why Google built it, because at Google, we have skillions and skillions of lines of programming code, programs that are executing all the time. And if you just think about the data centers that we have, if you can maximize how many threads are running at the same time, how much code is running at the same time, then it's a huge gain. If I were to launch a thread in Java versus launching a thread in Go, the thread in Go will actually have 1/100th of a percent of memory allocation dedicated to it. So you can do a lot more things with Go. Not only that, but the style of programming in Go is very similar to like Python or PHP or some of these like dynamically typed languages, but you get all the benefits of having it structurally typed. It's also very simple, which is like the premise of it. There's no build configuration. There's not that many dynamic libraries. A lot of the libraries are core to it. And so its principles are that it's simple, it's really easy to use. You can basically create a web service in 5 lines of code. It is really reliable because of how simple it is. And just by its nature, because the way it was built is really lightweight, so that it makes it really, really fast. Actually, when Go was first being created, it had to have, when we were designing how this programming language is going to work, it had to have unanimous consensus. Everybody had to vote that makes sense. If not everybody agreed on it, it didn't go to the framework at all. It also has built-in framework for testing, benchmarking, profiling of CPU, of memory. When I think about Go, to me, it kind of reminds me of, like, let's say you were to run a business, and businesses operate on money, almost all of them do, and almost all businesses pay taxes. Because you are programming in Go, and it's more lightweight and your foothold is smaller, you can do a lot more with it. It's very similar to running a business and paying less in taxes. And it's one of the few languages that are like that. And that it was made by people like at Google that are built for things being concurrent, scalability, and so there's these principles that are built in mind at a massive scale. So it's a lot of things that went into it that maybe you don't have to think about if you're running it personally, but it went into it to design the design of it. And because of that, if you actually look at Hired or some of these other websites, Go engineers are the highest in demand, or one of the highest, like top 3 at this point. I think last year it was number 1. Right now it's top 3. It's also one of the highest paid software engineers, period. And it's actually growing. The salary is increasing constantly. And the crazy thing about it is actually really, really easy to learn. Easy learning curve for a person or for a team. If your team decided to switch from C++ to Go or from Java to Go, it's easy. And the reason why I'm talking about it here is a lot of Detroit companies are actually moving to Go. So I don't have a lot of time. I was going to go into how it works, basically basic syntax, talk about the bread and butter, which is concurrency, which is very different than how other languages are doing it, and it's also built in. If I have time, I might go into an example of a JSON reader and show some testing, benchmarking, and profiling. Let me see. So those who have a computer and want to code with me to see how this works, you can actually download the Go library, the compiler, set it up on your computer. It's pretty easy at GoLang.org. Or you can just use play.golang.org, which is the playground that allows you to execute code online. So let me just show you a simple example of a hello world. So in Go, everything really is inside of a package. So a package is basically a folder that has contents, variables, functions, and anything that is accessible outside of that package is in capital letters. Anything that's private is in lowercase letters. It's very, very simple. And so every package has a name. And then you want to import whatever libraries you're using. The cool thing about Go that's different than almost most other languages is that, like I said earlier, it doesn't have a configuration file, which means the import statements can actually take GitHub repositories, Mercurial repositories. You can actually write right here, like import HTTPS, GitHub, and then write a library, or it will port it automatically. But similar to C++ and C, is usually a main function, and I'm importing the library FTM, which has a print line. So if you run this, now what it's doing is actually taking this code, is sending it to a server, is compiling it, running it, and sending what the response is. And if you can see how fast that is, this is like a server offline somewhere. And you can see this is not like something I did before. This is live. So this is just a simple example. Here is another example that I have. So in Go, the functions are a little bit different. So there are no classes. There are just functions and structs. And structs can have methods, and they can have multiple inheritance that's done implicitly. But their functions are very different because they have a lot more capabilities than a typical language, a typical compiling language. For instance, if you look here, swap actually takes in two arguments, x and a y, and returns, and these are both strings, and returns an x and a y. Like, I didn't actually have to say, I didn't have to specify one return. I can return as many things as I want. The other difference with Go is the syntax. I'm not sure if you noticed, but in most languages, you start off with the type first, and then later on you have the variable. And Go is backwards because as languages improved and evolved over time, they get more and more complicated. And if you look at some of the really complicated closures done in C++, they're actually really hard to read. And so at Google, we found that if you did the reverse order, readability is a lot easier. And like I said, this is made so that the programming language can be done quickly. So I don't have to do X string, Y string if they're both strings. I can just do X, Y, they're both in their strings. If I run this, then hello world is swapped. Do another example. Actually, let me see if I can increase that. In this example, it's a function called split. It takes in an integer and returns an x and y integer. So basically, it takes this and splits it and returns it. Normally, in a programming language, you actually say, I'm returning x and y. But in Go, it lets you set the variables inherently within the code and just does return. And because I said I want to return x and y, it pulls that out of this function. All this is done because basically we want a developer to be able to write really quickly. And so speed is very important. Speed is important, simplicity is important, reliability is important. So here's an example of concurrency. And I know you have your computers out, and let me know if am I going too fast? Let me know if I'm going too fast. I have an example after this that I would like some brain work, some brainstorming done. So typically with concurrency, you might have concurrent threads that are using the same variables. If they're using the same variables, you don't want the threads interacting at the exact same time, so you're usually doing like some kind of mutex or something like that, which over time, and depending on how complicated it is, can really slow down your programming, and it has to be done in a certain way, which is hard because a lot of developers you might want to hire might not understand that. It's hard for code reviews. It's something inherently built into programming languages that make development hard, which therefore makes the execution of that code to be unreliable. But in Go, you don't have to program like differently because you're doing threads. Because of the way they do this thing called channels, it makes it easy to program sequentially, but have the same capabilities of asynchronous programming. And I'm going to show an example of that. So let's skip down to this main function. Before I showed you that I can do var, hi equals hello. But also I can do just hi equals hello. There's many different ways you can write the exact same thing, but because you want to reduce how much work you're doing, how much code you're typing, because you're constantly typing code, there's a lot of shortcuts in Go. So in this example, s is a brand new variable, and it is an array of integers, which is denoted here. And these array of integers are taking in this array, 7, 2, 8, -9, 4, 0. So that's one variable being declared. Another one here is a certain type that's in Go, which is called a channel. So instead of having threads that are using the exact same variables, and they're modifying the same variables and doing mutex on the same variables and doing locks, instead of doing that, you can actually have threads that talk to one another. And it makes things a lot easier. And those are things, and the way they talk to each other is called channels. So you create a channel, and you can pass it to different threads, and allows them to communicate through that channel. So in this example, I'm creating C, which is a channel that takes in an integer. And so I want to explain those two first, but let's go back to this function sum. So sum takes in the first parameter is an array of integers, and the second parameter is a channel. So what it does is actually, it creates another variable, just sum that starts off with nothing, initialize it to 0, and then it goes over, it loops through all the different integers inside of S, and whatever's inside of S, it adds it to the sum. That's what this is doing. This for loop, just in case you're curious, this underscore is really this could be an index, so I could have had K. But because I don't care about the index, I'm doing an underscore. And V is actually so the first variable is the index, the second variable is the actual value itself. So once it figures out the sum of everything inside of this array, it sends that sum to a channel instead of being returned from the function. So if we go back to the main, in order to do concurrency in Go, the only thing I have to do is put Go in front. So now this function, sum, is being launched asynchronously. And then also, I have another sum being launched as well. So these are being launched at the same exact time. And they're both taking in C as a channel. And they also are both being passed in a sub-tier of that array, a slice of that array. So the first one's being passed in the beginning of the array to the middle. The second one is the middle of the array to the end. And in here, we're saying, I'm going to wait for the channel to respond twice. And the first response that comes in is X. The second one that comes in is Y. It doesn't matter which one comes in, what time. I'm going to wait for them. And then I'm going to print them together. So if you run this, it added these three numbers, summed them together, and then it added these three numbers, summed together, which is X and Y, and then added them together, which is 12. So this is a very simple example of doing concurrency with channels inside of Go, which is different than most other languages, and is built in to be fast. Like I said earlier, doing this launches these threads that have a really, really small memory footprint compared to doing it in Java. Because if you're running it in Java, it's not just running this new thread, it's also adding more allocation for memory for the JVM itself. Are any questions so far? All right, sorry.
So at the beginning, you mentioned that Go was specifically for they made it for a specific reason.
Right.
Could you explain what that reason was for, or is it specifically for computation?
a lot of times in development, yes, there are proprietary things that we want to make, but there's a lot of third-party things that we want to bring in to make the whole thing, work smoothly. Does Go have a lot of third-party support or whatever that may be? And I'll stop and let you answer.
All right, you asked a few different questions. Let me see if I can go through them. So yes, Go does have third-party support. There's a lot of libraries on GitHub, and you can import those libraries. They're a collection from Google as well as like the community. Why Go was created, like I said earlier, was basically for efficiency. It's efficiency and in development. Actually having a group of developers, a team of developers working on a code base, getting it done quickly. If I were to write this in C++, it would be a lot more lines of code. Mm-hmm. And the second one is running it effectively. For instance, I'm working on weather right now, so I'm pulling in weather from lots of different data sources, and I'm pulling in new files of weather every single minute from all over the country. And I need to take in all these different weather sources. They send me files in CSV format, JSON format, whatever. I need to take that data, make it unified, and whatever. And so I constantly have scripts going in and cleaning things up. And there's only so much. It's only so much a server can do. Once it runs out of memory, then you have to rely on another server. You have to scale. If you have servers like 10 servers that can do more, with just changing the language, having faster code, then it's a huge win, at least for Google's. So because it has its own garbage collector, because it's statically typed compiled language, that you're able to run it with a really, really small memory footprint. And so me writing this in C++ and writing it in Go, I actually have more threads running at the same time, doing more work between the different languages. So that's the reason why Google developed it, for those three reasons. And the third reason is that it's reliable. Because it's so simple, it's not that many things inside of it, it's fewer things can break. So it's for speed, simplicity, and reliability. Did I answer your question?
Yes. Yes, I did.
Is there another question?
So how is the GoLang going to transition into the automotive industry?
In the automotive industry. You mean at Waymo?
Well,
I don't speak for the whole automotive industry.
well, I mean, like, as in, like, like in automotive industry, like how they have like the software stacks, right? Where like I think it's the auto SAR protocol that like a lot of people use to make for their ECUs. So I was wondering, are people trying to position the Go language into AutoZAR?
So, I've never really worked at an automotive company. Mm-hmm. I would say that Waymo is an automotive company. So I can't really speak for the other companies, but at least for self-driving, there's a lot that goes into having servers talk to the car. Being fast, reliable. If you're driving, you're losing internet connection or whatever, the car needs to be able to talk to servers, figure out what the fleet's doing. And so, because safety is a concern, speed is a concern.
Yeah. So you brought up safety is Go language ISO 26262 compliant? That is the safety protocol for the automotive field.
So I can't really speak a lot on Waymo because it's confidential, but I'm mainly speaking on off-board, which is there's nothing inside the car. I can't really speak to what's in our cars, and I can't speak for the rest of the automotive company.
Over here.
Hey, awesome presentation. I love the language. My question is, so you talk about how this language was created to increase like efficiency, increase speed, and everything like that. Is the language used more as like glue, or
It's like what?
It's like glue. Like, is it like, are there frameworks that you can use to build something from scratch, or is it more you kind of inject it in between other code that's doing stuff? Like, how would you build something like, I want to build a whole web server that does something from scratch? Would you do that in Go, or would you use?
For sure.
Okay.
Yeah, you can actually build a web server in 5 lines of code.
Because I'm thinking of like Java, where you have like Spring, and JavaScript,
It's
where you have
way
like
easier in
Express and stuff like that. Is there
Way
stuff in
easier.
Go that's like a framework that makes it easy to build stuff, or you just build it yourself?
Absolutely,
Okay.
absolutely, yeah. It's way easier. If you just search for a web application in Go, you'll find an example online easily.
I'm coming to
I
you,
got
bro.
5 minutes? All right. Let me quickly go to some other things. Let's see. Where's that? So one of the things I wanted to show was testing in Go. So I got 5 minutes. Let me just quickly go over some examples. In this example, when I write unit tests, usually my unit tests are way bigger than that code I'm actually writing. But in Go, built in is really simple. So in this example, there's a test. I'm creating a list of tests that has, and basically I'm testing, in this example, I'm testing string.index, which is supposed to say, I'm passing in a string, and I want to find another string within inside this string, and give me where the index of where that's located. And so I'll have certain parameters up here that I'm going to pass into that function, and then I have an output of what I expect it to be. And so I go over this test. I pass in these parameters, and I get what actually happened. And I wanted to match it to what was expected to happen. If it doesn't work out, then I print out an error. And that's pretty much it for this test. If I were to run this, then it runs that test and it says it passed. Similarly, you can do benchmarking in Go. So here's a benchmark test where I'm testing the exact same functionality over and over and over again. It ends up testing it, I don't know, this many times. Let me see, 215 million times. And on average, the function completed this many nanoseconds on the computer that I tested it on. The other cool thing about Go is there's documentation built in. So anytime you write a package or anything like that, actually, let me just show that real quick. Oh, shoot, it's not working. I see what I did wrong. So these are just normal classes written in Go. And the Go documentation goes through, creates documentation for it automatically. And it does documentation for anything that's in a repository. So if you actually write code, upload it to a Git repository, you can actually point this documentation to it, and whatever code you wrote, it'll create documentation for it automatically. But if you can see, not only does it provide the function and what it does, but it also provides examples of that function. And the way it does that is, so you have testing, you have benchmarking, but you can also have documentation examples. So here, I'm passing in chicken, I'm looking for KN, and here I'm looking for DRM, and this is the output I'm expecting. And because I wrote this code, it actually pulls in that documentation here. And within the documentation, you can run it as well. The documentation is also considered its own unit test. So when you run it, it actually runs it and makes sure that it works. There's also CPU, memory profiling built in, and even if you're coding and you might make a mistake, there's vet which checks for common mistakes. So there's a lot of things that are built into the language itself that makes it very simple to use. You can program really quickly. You don't have to use a lot of third-party libraries, and it just gets the job done, to be honest. I write things in C++, I write things in Python, and sometimes I go back and I rewrite them in Go, and it's much better. It's smaller and it executes faster. All right, got 10 minutes for questions? All right, cool. Any questions?
Yeah, I had a question. So when you started talking about specifically with the channels, immediately my mind went to like piping and the event stream with Node. Like, is that a similar sort of overlap between Go and Node, or does the channeling serve a completely different function than piping would in Node?
It's similar. It's
Okay.
similar, but Node is interpreted, right? So that's the difference. Yeah. This is statically compiled. So it has a lot of the same capabilities, but it has like the best of all these worlds into one. 4 minutes? All right. All right, so let me go over another example. Here's an example with JSON. So let me just copy this. So a lot of people work with JSON. They work with XML. Here's an example of JSON where I have this string. This is blob. It's basically a string. It's a string of JSON. And like at least in my example, I'm constantly downloading files from other servers, and I want to convert that to something that's some kind of structure. And so I create this struct item. It has a title and URL. I want to convert this JSON to something that's statically typed. And so I create this array of items, and I can pass this blob into this string reader, code it up, encode it, and then decode it into items. And now if I can loop over my items and I can actually have it as these structures. And what's cool about this, like I can keep going back to the memory, is let's say I have this huge JSON, but I only care about a few different fields. Like let's say I don't care about title. I only care about the URL. Then I would remove this title. And what's happening is it actually ignores the title. So this is something that's now instead of having like this huge JSON structure stored in memory, I only have the things I care about stored in memory. And this really is just a few lines of code. And so if I were to do this in another language, it would be a lot more code writing. It would be a lot harder. It would take me longer to write. It would take longer for code reviews to make sure it's done right. People will ask me like, what library are you using? This is a core library built into the framework, not a third party. So everything's a lot faster. Development cycle, memory, and execution. So I think I'm out of time now. All right. I'm Bryan Campbell. I'll be around. Ask me any questions later on. Thanks for your time.